Good afternoon, ladies and gentlemen. Today we will be working on the zero product property. Our little man here says that 0 is a number too. That's true. 0 is a number. But I believe his comment about it being invented in the 18th century is a little bit off. I'm told that 0 was invented in India several thousand years ago. Well, maybe not several thousand, but the Romans didn't have the number 0. And once 0 came into the Arabic numerals, we could start doing multiplication. Well, we're going to be doing multiplying, and we're also going to be doing factoring. And with the zero product property, we will be able to solve equations, finally. Here's your vocab. Copy this down. The key to the zero product property is in these words. If two numbers multiply to get 0, what do you know about them? One of them, at least, has to be 0. So since we are going to be setting our polynomials, our trinomials, equal to 0 and factoring them, we are then going to set each of our binomials equal to 0 to solve. It's a neat little trick. We can talk about it some more in class. All right, so we're going to isolate 0 first of all. Move all the terms to one side so that you have 0 by itself on the other side. We are then going to factor the polynomial, which you know how to do. We are then going to write each factor equal to 0 and solve for the variable. And you know how to do that too. We can then check our work by plugging our solutions back into the original equation, and we are then going to graph on the calculator. For example, notice that we have our normal trinomial here, and we have added in equals 0. We do not want to start factoring until we have the equal 0 part. But we're going to factor this like you already know how. What two numbers multiply to get 15 and add to get -8? Answer would be -5 and -3. So I'm going to write x minus 5 and x minus 3. And I'm going to bring down the equal 0. And here's the new part. I'm going to write x minus 5 equals 0 and x minus 3 equals 0. I will then solve each variable, and I get x equals 5 and x equals 3. So the two solutions to this trinomial are 5 and 3. And then I'm going to draw a rough graph of what this parabola is going to look like. Anytime you start with x squared, you're going to get what's called a parabola. It's a U-looking thing, an upside-down umbrella, perhaps. Well, if x is 3 and 5, that means it's going to cross at 3 and cross at 5, and it's going to look something like that. Okay? All right, here's your U-try. You're going to do the same thing. Factor, solve for x, and draw your little parabola. Okay. Oh dear. Now we did say we had to isolate 0, didn't we? All right, so I'm going to subtract x and add 3 to both sides. Subtract x and add 3. And I will get 2x squared minus 7x plus 3 equals 0. All right, I've isolated 0 now. And I have a 2 in front of the x squared. So I need to multiply the 2 and the 3, and I get 6. And I ask myself, what multiplies to get 6 and adds to get -7? And that would be -6 and -1. So I write 2x squared minus 6x minus x plus 3. You know how to do all this already. Bring down the equal 0. Cut it in half. What's the GCF on the left side? 2x, factor out 2x, I get x minus 3. I know I want x minus 3 on this side, so I'm factoring out negative 1. Bring down my equal 0. So I get 2x minus 1 and x minus 3. Okay, all of that you should know how to do. So now I'm going to say 2x minus 1 equals 0 and x minus 3 equals 0. Add 1 to both sides. 2x equals 1, divide by 2. X equals 1/2. Over here, I'm going to add 3 to both sides, and I get x equals 3. So there are my solutions, 1/2 and 3. And if I draw the parabola, it's going to cross at 1/2 and 3. And it looks something like that. Now this is not absolutely correct, and we will be more precise as time goes on. So right now we're just kind of drawing a rough image of what our parabola is going to look like. If you want to watch all that again, please do. Here's your u-try. Remember to isolate 0, and then factor and solve. Now, what's the first thing we always look for when we're factoring? Right, the GCF. Is there a GCF? There certainly is. So I'm going to factor out 2x and divide each term by 2x, and I will get x squared minus 4x minus 5. Did I do that correctly? Okay, now since I've got a 1 in front of the x squared, I can ask the question, what two numbers multiply to get negative 5 and add to get negative 4? And the answer would be negative 5 and positive 1, right? So I got x minus 5 and x plus 1, and I have to remember to bring down this 2x. And now I have brought down my equal 0, and I've got 3 solutions this time. And how did I know I was going to get 3 solutions? Did I know ahead of time? I did. How did I know? Because of this exponent. This 3 tells me I'm going to get 3 solutions. So I'm going to write 2x equals 0, x minus 5 equals 0, x plus 1 equals 0, and I'm going to solve all 3. Here I have to divide by 2, and x equals 0. Here I'm going to add 5, and x is equal to 5. Here I'm going to subtract 1, and x equals negative 1. 3 solutions. Is this going to be a parabola? No, it's not. With 3 solutions, it's going to cross the x-axis 3 times. It's going to cross at negative 1, and at 0, and at positive 5. This one is going to look like this. Something like that. Don't know exactly where the curves go, but I do know where it's going to cross the x-axis. Okay, so that's solving quadratics, or any polynomial, as you can see. Here's your u-try. Remember GCF. Factor as much as possible. You should get 3 solutions. And that's pretty much it. We'll work on this together in class. So we're going to be drawing a lot of parabolas. We're going to be drawing a lot of parabolas now. P-A-R-A-B-O-L-A, parabola.